Without further ado, help me, Natalie.
All right. How was lunch? Good? Good? Cool. Can everyone hear me in the back? Awesome. Thank you. All right. So my talk is going to be on serverless server-side rendering. Kind of sounds weird, oxymoronic. What? Server-side rendering with no server? I'll get into that a little bit later. But first, I'm going to introduce myself a little bit more. So like I mentioned, my name is Natalie. I work at Zillow Group. How many have heard of Zillow? Whoa, that's cool. That was a weird squeal. All right. How many have heard of Trulia? Okay, cool. So I've been at Trulia for 2 years. Trulia is a part of Zillow Group, and that includes brands like Zillow, StreetEasy, HotPads, everything real estate related. I am obsessed with real estate, and this was the case before I joined Zillow Group too. So now, just on the job, I know a lot of random real estate facts and real estate trivia, including like what famous person bought what house here and there. It's kind of weird. So if there's ever a trivia category for that, I will win it. And as far as the technical stuff I do at work, I work with React. I've been working with React for about 1.5 years now. We initially started with a jQuery backbone framework, and then we had to refactor a lot of it over to React. I'm sure a lot of you were in the same boat at some point. And more recently, I've been writing my React components using TypeScript, which is really cool. We don't use Babel. We just use the TypeScript compiler and compile it down to ES5. I also work with AWS a lot, and I say cloud things in AWS because there are many cloud things in AWS. If you've ever worked with it, you'll know there is an infinite number of resources you can use for your architecture. And also their documentation is really beefy, which I really like. It seems like no matter what tab I click on, there's another tab below it, and you just keep going and going, and there's just a ton of documentation. We work with Node, obviously. We're going to need that for today's demo. And I put Terraform in there because Terraform helps us configure and provision the infrastructure that we want to build out in the cloud, but we want to keep the same state of that infrastructure from one developer to the other. So it helps us set up AWS in a non-manual way. So that's great. All right, Grumpy Cat. Many of you don't know, Grumpy Cat made that face when he tried to load a website that took too long. That is not true. But this Grumpy Cat, I mean, I feel like it's kind of descriptive of how we all kind of feel when we go to our mobile device, try to load a website, and it just takes way too long. Almost to the point where maybe you feel like there's something wrong with your phone or your device. But I mean, when you're building web applications, you've got to think of every kind of user. So users who are on really slow network speeds, users who are using devices with slow processing CPUs, not just your ideal case of working on the best type of CPU on a really fast network. Great, looks good for me, and then ship it. Not a great approach. So yeah, performance is a really big deal, and I feel like we can all agree on that. I don't really have to drive that home too much. But performance is important to consider just on the whole scope, but with server-side rendering, the user perceived performance is what is really improved. So we want to serve up something to the user as soon as possible so that they don't try to visit our site and then try to flip out to another site and we lose them, and that's really bad. So performance is very important for the user experience. But these are all fine and dandy, but the real crux of it is it's important for SEO. This all may sound like a repetition from this morning's talk by Sasha. It is a repetition. So for those of you who were trickling in this morning and didn't hear that, I'm going to reiterate it just so that we're all on the same level playing field of what server-side rendering is, why it's important, how to do it using AWS Lambda. Okay, so SEO is very important. So I've read online a couple times that people think server-side rendering for SEO is kind of a myth. I don't agree. And I've also talked to many SEO specialists at our company and wanted to get the actual facts from them. And they say it's very important for SEO because with all of the different search engine bots out there like Googlebot, Baidu, Bing, Yandex, you have to consider all of them, they pretty much give you on average a 5-second window to get something to the browser and to start indexing and parsing. 5 seconds is pretty fast, and if you're client-side rendering a really big web page, it might take more than 5 seconds, and then you miss that opportunity to improve the ranking of your site. Okay, so SEO is really important. Now I'm going to go into explaining server-side rendering. I found this really great image on a Medium article, or Medium post, I don't know how you call that, by the Walmart Labs engineering team. And I think it breaks it down really well, and I also am a fan of visuals. Not surprising since I'm a front-end engineer, but okay, so it talks about the different steps that go into making a request initially to get a web page back, and then executing JavaScript in the page until finally it's interactable. But what I want you all to focus more on is the bottom images. So at first you have that loading progress bar, which many users already don't trust because progress bars are kind of weird and they speed up at some points and slow down at other points, and it's like, how far along are we really to getting the web page? So we want to make sure that progress bar is not there for so long. And when you server-side render a web page, you're going to make a request from your client to the server to just get HTML back. It may not be in the same state that your HTML will be at the very end of all the executions in the browser, but it's just something to keep the user on your site and not have them bounce. Okay, so that's the first step. Second step, you get that HTML back, you render it. Your page is now viewable. That's awesome. Not only is it viewable to you, it's also viewable to the Google bots and the Baidu bots and the Bing bots, so that's great. And then in the background, you're continuing to load any third-party libraries you have, any other script tags and scripts that you want to include in there. And at the final step, it becomes interactable. So you can click on the buttons, you can fill out the forms, you can watch the videos you want to, and that's great. But the user doesn't know that at the very first time that they saw the template, it wasn't actually interactable, but they don't have to know that. Okay. We want to compare that to client-side rendering, which we're all very used to. Client-side rendering is a little bit different, but overall kind of similar. So you can see the bottom panel here looks very different to the server-side rendering one here. And in the beginning, you're going to make the same request to the server to get HTML back, but that HTML is going to include JavaScript that you want to include and execute in the browser, and meanwhile the user is left waiting and just looking at this loading bar that kind of sucks. And at the very last step, it's both viewable and interactable. So safe to say server-side rendering can definitely improve user perceived performance. But there are pros and cons, like with anything else. So the pros, like I mentioned, is SEO, and that's a big one. That's one of the key factors where companies are deciding to server-side render components versus client-side rendering it. Because SEO is very important to getting traffic to your site, and based on your business model, getting more money, improving metrics, so that's all great. And then improve perceived performance. I didn't want to say just improved performance because your web page might still be really big and it might still take more than 20 seconds to load everything, but that would happen after the fact, after you get that initial markup to render to the user. So it's improved perceived performance. So to the user, whoa, that looked really fast. It loaded very fast, which is great. Some cons. Added complexity. What I mean by that is you kind of now have to think about the overall timeline of the lifespan of your application and think of it in two parts. So you think of the server-side part and the client-side part. And debugging can be a little bit more complex versus just debugging in the client. And also, you won't have objects like window and document to rely on the server. So you need to account for those globals that you may depend on. Also, time to first byte may be slower than client-side rendering just because the server has to do a little bit more before it gives you a response, and then you move on from there. All right, so the pros and cons of server-side rendering. Now I'm going to show you an example. This is a real code snippet. Hopefully you guys can see it well in the back. This is a code snippet I wrote for a demo I'm going to show you guys a little bit later. But in this code snippet, all we have is an Express app that's going to be handling the requests coming into our application. So I have Express loaded in there. Also, this is written in TypeScript. That's why it might look a little bit weird compared to JavaScript, but it's just type definitions included in there. And we're going to have our markup handler handling the requests that come into our endpoint. So this is what the markup handler looks like. So when we try to get a resource from our endpoint, this function is going to execute. And the crux of this function is really line number 8, where it says const HTML. We're going to be using the render to string function that's exposed from the React DOM library. And render to string needs to take in a React element. So it's not like you can just include the component that you're importing. You have to create an element out of that component, and then pass that into render to string. And the result of that is literally a string that just contains your HTML that was rendered from the JSX that's in your component. All right, so we have that HTML, and we're using Express to just send a response of that HTML, and that's it. And this is the component, the Hello World component that I wrote. Just wanted to show you guys it's a very basic component. I have state in there, but it's not being used. It's just wanted to show kind of an example of this is actually a real component that I'm using to render it to a string. And the JSX is very simple. All I want to render is a hello Boston, not hello world. We are in Boston. Okay, so that's the code example. We'll get to that a bit later. Now I want to introduce AWS Lambda. How many of you have worked with Lambda before? Okay, that's pretty good actually. So Lambda, for those who don't know, is a function. What is a function? A function is something that allows you to run code server-side without you having to provision the server, scale the server, worry about its configurations, stuff like that. So for those front-end engineers who don't really want to work so much on the server, this is a really good solution. AWS is not the only cloud provider that has a function. Google Cloud has functions, Microsoft Azure has functions too. I'm just choosing AWS Lambda because I have experience working with it. And like I mentioned, I really like AWS docs, and there's a very good support system online for AWS issues and conversations. One of the main pros about Lambda is not only the on-demand execution, like I mentioned, but also the lower cost. I want to emphasize that it's not always going to be a lower cost compared to an instance. In some cases, it can be a lower cost. It just really depends on the size of the application, how much execution time you have. Those are some of the factors to think about when deciding to use a Lambda versus an EC2 instance or any other kind of server you want to use. And Lambdas are only going to charge you for what you use. So if there are times when your app is living on a server but it's not being used, you're still paying for that instance. You're paying maybe a flat rate for the size of that instance, and then maybe now on-demand execution time for that instance. Actually, Amazon just changed their pricing model this past week. So when I was preparing for this talk, I was like, oh wow, that kind of throws a wrench into things. But they still have various pricing models for instances, and Lambda is charging the users based on a millisecond level, whereas an instance is charging you on a per second level. And if you're using Lambda and you're in the free tier, your first million requests to Lambda are free. Every subsequent million requests is 20 cents, and so on and so forth. Another pro is the hassle-free scalability. So Lambda auto-scales in the sense that depending on the number of events that come in that are triggering the Lambda, it'll just copy itself, create copies, and just execute in parallel. So it auto-scales on its own, and you don't have to really worry about the scalability of your server. Those are all really great. Some cons, though. The initial load time may be slow, but for the subsequent invocations, it'll be faster. And that's just because initially on the first request, your Lambda is going to take some time to create that function and serve it up, at which point your code is executed and you get a response. And with Lambdas, you can set a timeout, let's say 3 seconds, as in I want to give 3 seconds to execute the code, and then I want my function to disappear. But your timeout can go all the way up to 5 minutes. So you can say, I want my Lambda function to be created, I want to have the code on it execute, and then after 5 minutes, if nothing else comes in, the Lambda will go away. And then every subsequent request in there will have that initial slow load time, and then fast load times after that, and then once it's gone forever, until it's back again. It's very ephemeral. And another con is the stage environments. So I wanted to mention this because in our experience of using Lambda in production, it's really hard to monitor like the dev environment for Lambda, a stage environment, and a production environment, because they just kind of come out of nowhere and go away. So one of the workarounds that we've figured out is you can monitor the version of the file that you upload to Lambda and call that the dev version, stage version, and production version, and track it using hashes. And that's not the end-all be-all solution, definitely, but there are ways to go around this con. All right. So Lambdas are great. Now I'm going to move on to API Gateway because we need a way to invoke the Lambda. So API gateway is not the only way to invoke a Lambda. You can invoke it in many other ways. Let's say you have a DynamoDB and there are new records being added to the stream. Every new record could trigger a Lambda if you wanted to. And there are other cloud resources that will trigger the Lambda as well. But we're going to use API gateway for our purpose because we're going to make a request to an endpoint to get that initial markup back. API gateway allows you to just create an API, give it a particular name, and then you can create endpoints in that API, give those paths certain names, and each path will have the relative methods that it needs to handle. So the get, put, post, and delete methods we're all used to. And the API gateway will take in that request, it'll create an event object out of it, and we'll pass that along to Lambda. So that's what's going to be the incoming object to Lambda for that to handle a request, which is why Express comes in handy there. And for our API gateway, we're going to have a Lambda proxy integration that will make the passing of that event a lot easier for us. So now I want to describe the overall architecture and structure of what we're about to build. We have the user, we have the browser, the web, and we have our API gateway. The yellow icon is API gateway, and the orange one is Lambda. So we're going to make a request to the API gateway. We're going to pass that event along to the Lambda. The Lambda is going to hit a node application that we have, and it's going to return HTML back to the browser. Simple as that. All right, now this is a step-by-step how to get started with this whole process. It might seem a little daunting at first, but I think after this process, you'll see that it's really quite straightforward, and hopefully you can get to try it when you go home. All right, so the first step is to create the Lambda function. Because if you create an API gateway, you're going to need to wire it up to a Lambda function, and that needs to exist for you to choose which Lambda to hit. So first you need the Lambda function. And with Lambda functions, you have two options. You can either edit code inline when you're creating the function, or you can upload a zip file of your application to that function. We're going to take the route of uploading a zip file because with React applications and using node modules, we're going to need our node modules that we depend on for our application to work. So zip files makes a lot of sense for us. And essentially what we're going to do is you're going to have a repo like you would usually have with any React application. You'll have that typical file structure that you have with components, containers if you have any, your Redux store, any actions or reducers you have for your Redux store. And we're just going to create a zip file out of that and upload it to Lambda. And that's what's going to handle our application. Third step is to create the API itself. And with any type of resource that you're creating in AWS, you're going to choose a region that you want this infrastructure to be built out in. For our purposes, I'm going to choose US East 1 because that's in Northern Virginia. But back where I'm from in San Francisco, we would use US West 1 or US West 2. So that's on the west side. Okay, so when we create the API, we're going to have the Lambda proxy integration. We're going to create a get method on it. Once the get method is there, we'll test it locally, make sure it's returning HTML, and then we'll deploy that API to stage. Stage environment will be production, because why not just ship it? And then we're going to invoke the stage URL after that. So this might seem like a lot of steps right now, but we'll actually go through it right now, and I'll show you guys how to do it. All right. So we have our AWS console. I've created an API before that works, but I want to do one from scratch so I can show you guys. Okay, so you click on Create New API. You have this new API option clicked on there. Let's give it a name. Let's call it Hello Boston. Hi, Boston. Okay, that's our API. Oh, maybe this is really tiny to see in the back. Hopefully that helps. All right, so we have one endpoint right now. We're going to create a method on that endpoint. You have all these options, but we're going to click the get method because our Express application is handling the get request. All right, so now we have a get method. And as you see, once you set up the get method, you need to choose a Lambda that it's going to trigger. So we'll click on Lambda function. We're going to use that Lambda proxy integration like I mentioned. We'll use US East 1. And I'm going to need a Lambda function that exists in this region. So it's not like you would create a function and it exists in every region. That function only exists in the regions that you give it access to. So for the sake of time, I've created a Lambda function that I'll be using And that's the name of the function. Click on that. We're giving it permission to access the Lambda function. And there we have one endpoint. So in a nutshell, we have the client here, we have the Lambda over here, and we have method request, integration request, passing it along right to the Lambda, and then back out again as a response. So let's test this out and make sure that it works. Jeopardy theme song right now. So see that the initial load time is kind of taking a bit. That's because it's trying to be served up out of nothing. And our response body is HTML. Cool. So we have that markup that we just rendered server-side on a serverless resource. And we have the Hello Boston that we want to see, which is great. So now that we know that it works, let's deploy it. Deploy to stage. Let's create a new stage called prod. Production. Why not? Okay, so you deploy it out. Once you deploy it, you have this invoke URL. Kind of looks ugly, right? You can definitely hide this behind a DNS of your choice, but for the sake of time, I won't be doing that today. So let's hit this URL. Hello, Boston. There we go. So our markup was rendered server-side using AWS Lambda. That's not what I wanted. All right. So hopefully, as we look back on these steps here, it now makes sense. I know at first, as a first time seeing this step, or this list of steps, it might be a little overwhelming and kind of like, what am I doing? But it was pretty simple. But it was a very manual process, right? So we can't rely on every developer on the same team to create this architecture exactly the same every time. There should be a better way to configure that. And there are solutions to this. Terraform is a very popular one. It's developed by HashiCorp. And serverless framework is another good solution. Serverless framework is really good for architectures that require API gateway, Lambda, a serverless architecture. Terraform does that and more. Terraform can handle configuring RDSs, DynamoDBs, S3 storage, many other resources that you have options for. And what these allow you to do is it allows you to provision infrastructure for different cloud providers. So it's not just AWS specific. They also support Google Cloud, Microsoft Azure, and I encourage you guys to look into it if you want to take this to production. And here's just a very small example of what the Terraform configuration looks like. This is taken from the HashiCorp documentation, and this is an example of how you would create a Lambda function. You would give the Lambda function a particular name, and the file name is going to be equal to the name of that zip file that you created in your project. What I've done is I've created a script in my package.json that zips up my whole repo, and that includes the node modules and everything like that. And because I wrote it in TypeScript, what I'm zipping up is the transpiled code that's transpiled to JavaScript and zipping that with the node modules. So we'll set that file name here to equal the name of our zip file. And then we have a function name, which I named it SSR React East to indicate the region. You name that there, and you just move on through the list of the parameters that you want to set and configure for your Lambda. And Terraform files, when there are a lot of resources to build out, may look really confusing, kind of weird. But if you break it down to its simplest part, which is just one resource like this, it looks understandable. So that's great. Okay, so the overall goal of this demonstration was to show that you can server-side render your React components, and you can do it in a serverless way. The pros of doing it in a serverless way could be a cost reason. So it could be cheaper for you to render your React components serverlessly if it makes sense for the size of your application, if it makes sense for the level of traffic that's going to be coming into your API gateway. And you can compare that to an instance approach where having a server of your choice with a particular size. Performance is one of the things that we wanted to keep in mind. So we wanted that user perceived performance to be really good. And hopefully you can take this back and try it out yourself. I have links in here to the repos on my GitHub that will include my whole repo of the Hello Boston example, and there's a README in there to show you exactly how you can run it locally on localhost and then create a zip file and upload it to Lambda and so on and so forth. And I have a link also to the slides here, so if you wanted to look back at the slide with all the steps on there, you have that as well. And if there are any questions, you feel free to email me and also DM me on Twitter. Thank you very much.
We have a few minutes for Q&A if you want to do a couple questions.
Sure.
So with a service architecture, you're spinning up instances as you need them. So there's a chance that one of your users is going to hit a cold instance and have whatever the startup time being 5 seconds or whatever. Is there any way that you've mitigated that?
Yeah.
Like, especially if you all of a sudden have a spike in traffic.
Sure. And you're talking more about the serverless Lambda, right?
Yeah.
Yeah. So he was talking about if there's any way to address the issue of the initial load time of Lambda being very slow. And there's something called hot loading. You can have something running as a small job, a cron job even, that just hits your endpoint every so often just to fire it up so that when a real request comes in, it'll return your response a lot quicker. Another thing is you can enable caching on your API gateway so that it can cache the response of that HTML and serve it up a lot faster with requests coming in after. Yes?
So if your page loads without any interactivity and somebody clicks on it before the interactivity has been instantiated, is there any way to prevent them from just thinking the page is broken and isn't working properly?
So the question is, if your page loads really quickly with no interactability and the user clicks on it and it's not interactable, is there any way to prevent the user from thinking the page is broken? That's a good question. They may think it's broken if the rest of your website takes a lot of time to load. So this is one step in an overall goal of achieving really good performance for your page. That one step is to server-side render it and just to get something in front of them so they don't bounce and leave your site. Hopefully, with that in mind, you're also improving the load time of the rest of the application and the rest of the page. Steps that you can take to do that are by loading the minified versions of libraries and maybe rearranging the order in which you're loading certain resources in your DOM so that it can prioritize certain resources over the other and overall improve the performance of your page so that they don't think it's broken. So hopefully that time span in between viewable and interactable is small. And hopefully everyone's goal is to make that even smaller. Yeah.
What are some techniques that you've seen for managing version control across Lambda functions as your application grows?
So I sort of mentioned that. Well, version control, I guess, would be different. You could version your API endpoints. That's one. In terms of versioning the file that's uploaded to Lambda, you can version those files and store them in some type of storage, like S3 is a solution that AWS gives you. And you can attach a version number or even a hash that maps to a particular version number to the file name and then upload that file to Lambda each time. So it's more of like controlling the versions of the files that are uploaded to Lambda versus controlling the Lambdas themselves. That's hard to do.
Let's do one more question.
Okay, go ahead.
On the best practices when you're doing serverless, do you find you're making one bigger, almost monolithic Express application, or are you breaking it down into separate lambdas for separate microservices?
So that's pretty much up to you. You could go either way. We've implemented in a way where we have a monolithic type of application that is just on one Lambda because the application that we're thinking of is not that big. Granted, it could spin up out of control and become a real monolith, at which point it would be an issue. But what you could do is with Express, you could just have different applications that handle different requests. So instead of having one file that handles every possible request to every endpoint of your API, you could break that up into pieces and upload the relevant zip files to those. So it'd be more of a modular approach. All right, thank you.
All right, we're going to swap fast and go into the next talk, but I'll give us a couple minutes just to swap mics. So yeah, one more standard talk here, then we have 4 lightning talks, followed by the break. So we're going to go right into it. I'll hand it over to Brian to tell us about CSS in your JavaScript, or lack of CSS in your JavaScript.
Hello, everybody. Delayed applause. Thank you. My name is Brian Huff. I am the co-creator of Polish, which is a CSS-in-JS library. I also am a director of engineering at New Relic. And I'm here, unsurprisingly, to talk about CSS-in-JS. Hopefully, all right, I like it. There we go. How many of you have used CSS-in-JS before in production and enjoy using it in production? All right, so I'm going to need you to protect me from the rest of the people that might start heckling me during this talk. But friendly disclaimer, there are a lot of opinions in what we do. CSS-in-JS is certainly no exception to that. A lot of what I'm going to say are also going to be opinions. Take them with the same grain of salt you take everybody else's but your own, of course. So, awesome. So CSS-in-JS is relatively newish. We're still kind of trying to figure it out. I have been in web development for longer than I'm going to claim because it'll say how old I am. I've got gray in my beard, just take that. A lot of the initial reactions were mixed. A lot of the heroes that I grew up following in the development community, not super stoked about it. Here's some of my favorite quotes. Not to throw shade at Zeldman, but if you're asking somebody to go check something out from a library, it might be a little outdated. Just saying. But it goes to show you that there's definitely some resistance. In order for CSS-in-JS to really get a foothold, these are the folks that need to be bought in, because it can't just be us React developers that are off doing our own thing. Like, to reach critical mass, we need these folks to be on board. Cry for help is a little harsh, to be honest. I shed a tear or two at that one. But so there's a lot of myths out there about CSS and JS. Some of my favorite quotes, I've changed the names of these developers to protect them and their Twitter accounts. My personal favorites. I gave this talk a few weeks ago. Somebody got really mad at this part. They loved their inline styles, and they harassed me on Twitter for a while. But so there are some common myths about CSS and JS, that we don't know CSS, that we hate CSS. It's the same thing as inline styles. We don't care about separation of concerns, and we just want to write everything in JavaScript. So I want to quickly address some of these before we move on. So is CSS-splaining a thing? Well, actually, let's start off with that. We don't know CSS. So surprisingly, you need to know unsurprisingly, you need to know a lot about CSS in order to write a CSS and JS library. I know more about CSS now than I ever have at any point in my career. When you're trying to duplicate everything that CSS does in JavaScript, you need to know what it's doing. 2, we hate CSS. We actually really, really like CSS. We're just trying to move it forward. The big challenge with CSS is it doesn't have the open platform that JavaScript libraries give us access to, where we can go and try to move things forward. We can't create things like Webpack and Babel and things of that nature as easily. We're just trying to do this not to replace CSS, but to show what is possible in hopes that the powers that be in charge of CSS will implement some of these features. The third is that it's just inline styles. This is kind of our fault. The initial implementations of CSS and JS did use inline styles along with all of their limitations. I apologize for that. Unless you're that person who really likes it is in this room, then they're great. Separation of concerns. We do very much care about separation of concerns. We're just kind of changing the model. For those of you that have followed CSS and JS, this probably looks familiar. You've seen this floating around on Twitter. We're just changing the way that you look at it. It's no longer we have this single document that separates your JavaScript, your CSS, and your HTML. We're now doing it on a per component layer. I think it's very easy to focus on where we're writing the code as opposed to where the code ends up. Just like with JSX, where people got really super angry about it, we're really just compiling down to CSS in this case, just like we are with JSX and HTML. So the separation of concerns are still there. We just want it to be componentized, just like React. And we want to write everything with JavaScript. And this is probably true. One of the major reasons why people use CSS and JS is because I can write in the same file. Everything else I'm going to talk about is really great and exciting to talk about, gets developers really excited, but the average user of a styled components, of an emotion, of a glamorous is using it because they want to write their CSS in the same file where their JavaScript and their JSX is. Kind of hard to blame them for that, so I can't really say that this myth is untrue. So when I'm referring to we, I'm talking about the CSS and JS community as a whole. I like to think we're a fairly integrated group of folks where there's not as much competition to be like, oh, use us versus them. We're trying to move the whole thing forward. So when these libraries were created, what we set out to accomplish is a few things. One, portability of components. How do I take this component I've written and give it to another developer, another repo, another project? Portability of styles, which is slightly different. I'm doing all this work. Think of it as like a Sass mixin. How do I give this mixin that I've created to another developer? Better handling of critical CSS. So critical CSS is that concept for any of you who've spent a lot of time dealing with Google page speed and page rank, is that concept of how do I show only the critical CSS so that I can render this page faster? And last is platform agnostic styling, or what we've really just been trying to create in general with React, and this is kind of the last missing piece, is how do I write one piece of code that works across platforms, that works everywhere? How do I get it to work on mobile, AR, VR, etc.? So we're going to talk first about portability of components. So there used to be, well, technically there still is this concept of scope styles. For those of you that follow the Polymer project or are more familiar with just web components, generally speaking, it was this beautiful concept of writing CSS that was scoped to a single component and never collided with any other styles. You know, all those jokes and memes you see about CSS, this was supposed to fix that. It did not, because they made it go away. So let's look at a very, very basic component. You have your very basic button here, and I've created this button, and I want to share this button with other developers in my organization. I want to share this button on different projects. So a component library is a perfect use case for this. I want to create this overall styling that my entire company uses across various projects. In the past, I would have this CSS, probably a lot more of it, but it looks basically like this, and I need to get that to the developers along with my React code. How would I do that? You can manually cut and paste, which I'm sure there's a lot of you that are guilty of doing that. And this is really what we've done, right? You go and you look it up on GitHub, and even in like React libraries, like a React calendar, it'll say, take the CSS in this file and paste it into your CSS solution of du jour. Manually share and import a file. So those of you who are using Webpack, there's a whole concept that Webpack got notorious for is, you know, let's pull all the text out of that CSS file, stick it into a single CSS file, and we can have that import that we just desperately want, which I think reiterates the fact that we really just want to write everything in one file. So if we can just put that import statement, we don't care what's happening behind the scenes as long as it does that thing that we want it to do. It requires users to have that specific build. If I'm trying to do a third-party library, it is a pretty high barrier to entry to say, in order to use this library, you must be using Webpack with this particular plugin, or you must be using Gulp with this configuration. Anything of that nature creates a level of resistance that we don't like to acceptance of third-party libraries and need to bring styles on board. So how can we fix this? So a lot of my examples are going to be in style components. I'm slightly biased because I'm on the style components team, but it will look essentially the same for any CSS-like API. So whether that's Emotion or Glamorous, whatever the current cool thing to use is, it will look similar to this. So now what I'm able to do is I'm able to create this button here with the styles on board. I've got this in a single file, and then when somebody imports this file, whether directly from the project or whether I create a third-party repo that they're npm installing, all this stuff will come on board automatically and quote-unquote just works. And this becomes more powerful when you start to share styles across components. So now I have multiple buttons. Those buttons need to look slightly different, but they need to share styles. And now I have 50 buttons that I use in my component library, and those 50 buttons now all have their styles on board. This is really good, again, for third-party libraries. Styles with third-party libraries in React are a challenge. Are they using Sass? Are they using CSS? How do I support those means, and how do I do it in a way that the developer can't get in trouble? Because for every one of us that is writing one, there's thousands out there that have no idea how we did it and just want to install it and use it in their project. Internal component libraries, this is how I got into this. My previous company, Bleacher Report, was building a component library across the organization, and we needed to be able to share those components across, and we would do a lot of slacking of style sheets to each other, which is a horrible way of doing things. And then shared styles and style guides. Actually, we've had a lot of designers on the team that got really excited about this because they can bake the styles directly into our style guides. So when you combine that with the power of a component library, you could literally go search for something, click one button, and install the entire component with its styles directly from the component library and style guide, which is pretty powerful. This does bring with it challenges, though. We can end up with a lot of unrelated CSS. My CSS doesn't know about somebody else's CSS. Even the CSS I wrote on one component doesn't know about the CSS on another. And this is the problem we have now. If you install two very different libraries that just happen to use a lot of the same base styles, say even like a reset, how do I stop that from bloating my CSS? And we've drawn inspiration from a lot of what the CSS community has done to try to solve this problem. So Nicole Sullivan's object-oriented CSS, Jonathan Snook with his SMACs, and BEM from Yandex. And the concept here is like, how do we stop these collisions? How do we make it so that we can have something that doesn't collide but describes itself well, that if I need to use it somewhere else, I just know to use it. So BEM is this concept of block element modifier, and it's basically an internal mental model for you to remember how you're going to style your buttons. If I have the base, my button, all my buttons will have that, all my submit buttons, and then the active state. That is a lot to remember in your head for anybody who's tried to use BEM. Absent of the fact it's a little ugly, it's also really hard to remember. How do I share that knowledge across multiple developers in an organization? I end up writing all this documentation. It's just not native to CSS. So if we go back to our original example, I have a base button here that has white text, very basic, but then I can style it by extending it and adding these other colors. So how do I keep this from creating these duplicate styles? And what we do is we hash those styles. So while we end up with arguably uglier classes, you don't have to do the work yourself. So what we do is we hash the content that is made up of the styles, and that hash becomes the class name. So what you can do then is if I have something that has a white text on a button and some other third-party library has the same thing, this method is going to actually hash those to the same hash and keep me from creating duplicate styles. So it gives you that extra layer of safety automatically as part of the library, which is a huge win. You're not trying to keep the mental model in your head. You can use your code or somebody else's code, and you're not bloating those styles unnecessarily. Next, I want to talk about portability of styles. So if you take your standard mix-in, that is what I'm talking about with portability of styles. This is not the concept of sharing an entire component. This is the concept of taking a fairly convoluted concept in CSS that you've come up with a solution for, and you need to port it to other areas of your code. So this is a Sass mix-in for a fairly complicated concept called CSS locks, which is without going into too much detail, is this concept of fluid responsiveness between breakpoints. So if I want something to grow on a certain curve across like 300 pixels to 800 pixels, this is what that does. So as opposed to just jumping, it'll actually scale. Fairly complicated. This is what it looks like in Sass. The beautiful thing is this is what it looks like in JavaScript. Not too different. I mean, JavaScript, it's a function, right? There's nothing magical here. You don't need a library for this to work. This is just what it does. So I create this, and now I want to share this as a third-party library so I can get lots of stars on GitHub, or so that the rest of my company can turn around and use this. Now what you end up with is an installable component on NPM. Just do an npm install, you import it just like any other function, and you can use it directly either as an object or as a string interpolation, depending on the CSS-in-JS library that you're using. This is far easier than practically anything you've probably tried to do with Sass mix-ins because we have this infrastructure of NPM and Yarn everywhere. You know, Bower, another thing we can pour something out for, tried to solve this but wasn't really able to. This gives us that infrastructure that we already have, we know, and we use across the rest of our React code base. And this, advertisement time, is how we were able to create Polished. And Polished is essentially just 60 odd of these exact things, just a lot of these repeatable functions that you use everywhere. If you've ever used Bourbon or Compass or just the built-in Sass or less mix-ins, this is those ported over to JavaScript. You can import one of them, you can import the whole library. This is the power that being able to do this in JavaScript gives you. So the next thing is inlining of critical CSS. So critical CSS, as I mentioned earlier, is this concept of what is viewable on the page and what CSS do I need only to do that. If you imagine a single page app that I'm sure we've all created, there's tons and tons of styles that we need, but I may only need 2% of that to render that initial page. And the whole concept of this is I can only render that initial 2%. I only need that initial 2%. My page will load faster because I'm not bringing all that extra CSS on board. This is incredibly hard and complicated to do from a build standpoint. For anybody who's tried it, it's not easy. It's a fairly manual process for most folks. It's going in and figuring out what that CSS is and literally cut and pasting it into your head. There's some build tools that try to do this. There's a tool out there called Critical that is trying to take screenshots of what shows up on various breakpoints and figure out what CSS it needs. And there's a lot of work for very little effort. How many people have actually tried to do this? Wow. Just turn around and look, there's about 3. So this is a lot of effort for what is viewed as not a whole lot of benefit. But what if it just took this? So any CSS-in-JS library that is rendered server-side by the way that CSS-in-JS works does this out of the box, because only the components that you need for that first page are going to render, and therefore they're only going to call their CSS, thus injecting it on the server side, and you get it basically for free whenever you're doing server rendering. So it's another benefit you get out of it with no work on your side. If you're doing any server-rendered React, you just get it as a feature. The last, and probably the most future-looking but most important to me, is styles for every platform. The whole reason React existed initially was we started to do this concept of we can componentize things. Oh, if we can componentize things and I only have to write this code once, could I write this code once for every platform that I need to target? That's why we have such crazy things as targeting React to a Word doc for, I don't know why you would do that, but you can do that. And the big challenge here is styling is still very different across platforms. You can't just use naked CSS on iOS or Android. There's all these quirks and things that you need to do, but that's what we want to do, right? We ultimately want to get to this point where I can write this component and I can target it anywhere, and we can fire all the mobile devs and JavaScript rules the world. Like that's the goal. Sorry for any mobile devs, I really am. So we have this concept of React primitives, and React primitives is trying to solve this from a component level. If you've used React Native, you've probably seen a bit of this. It's this concept of, let me create these primitives that will translate to specific types of components based on the target platform. So here I have view, text, and image. That could turn into like a web view in iOS. It could turn into just a div in JavaScript and HTML. This is kind of what we're trying to do now from a JavaScript standpoint. So what if I could do the same stuff that I'm doing CSS-wise and get that same benefit, where we're translating the code we know to the code that we need? And I go through and I write what looks very much just like CSS, but we make the tweaks that we need to in order to style for that particular platform. And that is what things like Glamorous Native and Style Components Native are attempting to do, which is find all those idiosyncrasies, find all those differences between the different target platforms, and fix them for you so that you can just write CSS. So styling primitives could look something like this. This all looks just like CSS. It's probably stuff you've done in the past. But you can take any non-CSS property and write it like it would be CSS, and we'll do the translation. Now, this is the holy grail because we haven't achieved it yet. There's a lot that goes into this. One of the biggest challenges is just units of measure, for example. Like, we're very much all over the place with units of measure in CSS, so we've relatively said percentages, rems, ems, things of that nature. They use pixels without units on mobile platforms. How do we know that's what they mean? We don't have good answers to those questions yet because those aren't technical challenges as much as they're just like us trying to agree to a standard, which, as you all know, is much harder than the technical challenges that we deal with. But we're getting there closely. This will deliver on the promise of the same code everywhere. This is that last piece where you can write that component and you don't care who's installing it to what platform. It's just going to work the way that it needs to work. So this is all great. This is wonderful. I'm super biased. Nothing wrong with all this. This is all wonderful. There's things that we're still working out. There's this concept of form versus function. And form versus function, if you've used any of the earlier CSS-in-JS libraries, or you just prefer the object-oriented approach where you're just writing your styles as objects, there's that concept, which usually ends up with a much lighter library because we're not trying to process all that CSS. We're not trying to do things like what post-CSS does and things of that nature, versus a CSS-like API, which is more what you see with style components, with emotion and glamorous. And this is where we're trying to find that happy medium where, in order for this to get large adoption and for us to kind of shed that feeling of we hate CSS, it needs to be able to have a CSS UI developer who doesn't know a ton of JavaScript be able to come in and write it. We can scoff at that idea, but if we want mass adoption of this concept, that has to happen. And so that is what we're currently fighting, is do we go with these smaller libraries that, as JavaScript developers, feel great and they only add a couple KB and it's wonderful, or do we provide that more nice CSS-like API for users so that we can get adoption at the price of a larger library? There's also the concept of no config builds versus better performance. And this is kind of the intersection of the previous bullet point, because there's libraries like Emotion out there that provide a CSS-like library without the large library footprint, but require you to do the Webpack work. Webpack is very synonymous for us. We use it. It's tied to the React ecosystem. You step out of our little bubble, it's not used all that much. There's people out there using Grunt and Gulp and just NPM scripts and things of that nature. So there is an overhead to asking developers to configure their build in order for the library to work. I've brought up Emotion a lot in this talk because it is the one trying to bridge that gap. Emotion by Kai Hohenberger is a CSS-like API for those of you that have used style components without the performance hit. It does very little at runtime. It doesn't have post CSS on board in the library itself because it's relying on the Webpack build to do all that stuff for you at compile time when you build your bundle so that you don't have that hit of performance. Downside is obviously you need to be using Webpack and you have to have the Babel plugin. But for those of you in this room, if you were going to start a CSS and JS project today, this is what I would use because you're comfortable with Webpack, you understand how to configure it, putting a plugin in takes 2 seconds for us, and you get all the benefits of that CSS-like API. So if you needed to have a UI developer dive into your code, guess what? They're going to be able to write the CSS directly in there, and you're not taking the runtime impact or the bundle size impact. Security is another thing. Who would have thought that taking user input and executing it without thinking about it would cause problems? There's things specific to how CSS-like APIs work that cause a bigger problem because there are some security issues in string interpolation and tag template literals that will execute very without thought code that anything you put in there is going to cause problems. So you do have to take the extra work that if you're for some reason accepting user input to say create a theme or something of that nature, you're going to have to sanitize that input to make sure that you're not going to have any security issues once you go and run that code at runtime, because a lot of this is still being run at runtime. These are some great articles that I would check out. James K. Nelson did a study on all the things you can do to break things with CSS and JS and how to get around it. And then Matthias has the CSS escape polyfill, which is a polyfill for CSS.escape, which is a method we'll eventually get in browsers that allow us to escape out these user inputs so that we don't have to. They have done a ton of performance benchmarks, both on the size of the library as well as their runtime impact in various situations and the various modes that they all offer. If you're wondering where to start and you don't want to listen to me about Emotion, this is the place to check it out so you can kind of get an idea of the trade-offs. Another great blog post / talk to check out is Unified Styling Language by Mark Dalgleish. He is not part of the CSS and JS community. He's actually working on a competing standard called CSS modules, but he took a really good look comparing what he's doing to what the CSS and JS community is doing, where we overlap, what the differences and benefits are. Definitely worth 30 minutes of your time. If you think this is all horrible and you want to throw fruits and vegetables at me, there are other options out there. CSS modules is probably the best non-CSS and JS solution trying to solve these same problems. Definitely worth checking out. Polymer and web components are still very much a thing, a standard that they're trying to move forward. This is a good opportunity if you think there's better ways to solve this problem to get in early and try to be part of that problem solving, because this is very much an unsolved problem. There is the old tried and true Webpack CSS loader if you just want to put that import statement at the top of your component because it makes you feel more comfortable, like you can continue to do that. And then CSS variables are actually a very powerful part of CSS that will do things that a lot of the CSS and JS libraries will do without the extra library load. These can be updated by JavaScript. There's APIs to do that. So if you're just really wanting to set and update values for theming, you may not need all this craziness and you might be fine with just CSS variables. And I just kind of wanted to end this with a tweet from Sunil Pai, who is I call him the grandfather of CSS and JS because he created Glamour, which a lot of these libraries are based on. And he says, I don't want CSS and JS to win, I want it to be obsoleted. And that's really our goal. Our goal is not to replace CSS and JS. Our goal is to move the platform forward, so hopefully that the working group will take notice, start implementing these things in CSS, because we don't want this extra runtime impact. We don't want all these extra libraries. We don't want to have talks about which one to choose. We just want this stuff to work. So if we are successful, these things will all go away, and we will just get all this stuff in CSS. Thank you all very much. You can find me on Twitter at @b_huff and my GitHub there. And then if you are using CSS and JS, I'd love if you checked out Polished because it does give you a lot of cool tools. And that's it. Thank you all very much. If anybody has any questions, I usually reserve them you can find me outside. But if you want to stand up and tell me how much it all sucks, we have 5 minutes to do that as well.
Yeah, we can save Q&A for later if you want. We're going to jump into lightning talks. So grab him afterwards. I'm sure he'll stick around for a little bit. So we're going to do 4 lightning talks back to back to back. I won't do intros for each person. We're going to kind of just roll through them as fast as we can and then go into our afternoon break with snacks and coffee. So come on up and we'll get going. Sure, yeah. This will be 10-minute talks.
Pretty nice.
This started quickly. Hi, I'm Vincent. Today I'm going to quickly try to talk about the road to layout animations on the web. And that's important, the road. We're not quite there yet, but we can do some experimentation and see what we can come up with. So first, I want to talk about, sort of clarify what I mean by layout animations. And really my first experience with layout animations was in React Native. And React Native has a beautifully simple API. It's a single function really, where you configure your next layout animation with duration and easing functions. You define that all here, and you call this right before you update state that would likely change the layout, and then it will just transition that change in layout. So for example, if you have this red box and you have some style which updates the top and width, instead of it just snapping to that new top and width, it would do something like this, where it just transitions between those states. So when I started first looking at maybe any existing work out there for layout animations on the web, I found this article back in 2015 by Paul Lewis, who's a member of the Chrome team, and it talks about this idea of flipping your animations. So flip stands for first, last, invert, and play. And if we quickly go over what each step is, first you have the initial box, sort of where you're starting at. You measure the dimensions and position, and then you apply the new layout, and this is last, and measure that dimensions and position. And then you take those two measurements, you determine the difference between those measurements, and you invert them, but apply them to this box as transforms so that now it's in its previous state, at least visually. And then all that's left to do is you animate the transform back to 0, and now you have your layout animation. So when I was thinking about this, it's a very imperative API. You call this all at once, whereas this layout animation API in React Native, there are 2 operations because you're hitting that configure next and it's reacting to layout. So really, it's 2 sequences of operations. You have the first where you execute this on the configure next, and then layout changes. And then once layout changes, you react to that by performing the rest of the steps. But that layout change is difficult. How do we do that on the web? There isn't really a primitive like that, and you need to be fast. It needs to be after layout's been calculated, but before paint has occurred. Because if you don't do that, you're going to see a flash of that resulting layout before it gets animated. So in my research, looking at all the latest APIs basically the specs of upcoming APIs, the closest thing I could find was Resize Observer. Now, Resize Observer is an interface for observing changes to an element content's recs width and height. Now, that's right, that's width and height, not position. So I was kind of bummed because there isn't a position observer. But when I started messing around with it, sort of luckily for me, because this is only available in Chrome Canary behind the experimental web platform features flag. Lucky for me, their implementation is buggy, in that it does report on position changes. So if we're to modify this system, we have, in that first step, we start observing on that configure next call, and then once the layout change happens, it calls this second step, and the first thing we do is stop observing the elements. We only want it to execute once after we call configure next. So, and this is basically it. It's actually a pretty simple, and it is fairly robust, but there are still some remaining challenges. We're using transforms, and when we're animating changes in dimensions with transforms, we're using scale, which means we're stretching and squashing things. And that's sort of, there have been some efforts to solve this problem, but they're all not quite the most stable. So this means, like, you know, if you have elements with children, elements with bitmap content, like images, elements with borders or shadows, like these are all just going to be looking a little distorted. And then just text in general. So because I have a bug that I can leverage, I do have a little bit of a demo as a proof of concept at the very least to show what it would look like. And the thing is, you've actually been watching the demo the entire time. So this is a little just contrived example of, you know, we can change the layout between two states. This is changing flex direction row to column. And if we look, we can confirm that that's all that's happening. And if we uncomment this piece, now we animate between. And what's even, I'm leveraging the Web Animations API, which is another kind of up and coming. And if you notice, there's no artifacts. You don't see those transforms happening on those divs. It's literally just flex direction changing. So as a next little example, this is basically, I wanted to change every single Flexbox property I could possibly find and see if it could still hold up. And yeah, it does. But if we can change between these two states, then why can't we animate between the actual demos? And it works. Next, if we have these elements that are relatively positioned and we want sort of a collapsing animation of some sort, why not just set them all to position absolute so that they don't affect each other? And if we want to get even more crazy, so now this is in a scroll container, what if we promote a few of the elements to fixed position? And finally, we're doing some cutting edge stuff right here. So let's use some cutting edge layout, CSS grid, and even that, designer's eye, there's not enough white space. So let's add some grid gap and white space. So yeah, this is basically what I've been working on. This will probably break in the future, considering it's a bug. But I think it's really cool to think about these problems and think about possible solutions. And this sort of proves that it is possible on the web. And so for a last thing, I think we can just update this. And yeah. This. Who's next? Yeah. Any quick questions?
I was just wondering, mentioned before the user challenges. Are user challenges even possible given for custody problems?
Giving the what problem?
For custody problems that certain geometric transformations don't have one or one identification.
So in my initial research, the one thing that I do see as impossible is border cells. I actually do think that children, you can do it via scale and it won't distort. It is possible. And actually, Paul Lewis has another article where he sort of goes over that technique. It's basically every single child of the element, you apply the inverse scale transform. So they'll just be maintained. And that does work.
Thank you.
Yep.
All right, cool. So let's talk about React Native now. Something that layout animation came from first. So just opening, my name is Stan. I work at a company called Modus Create. Anyone's familiar with us? If not, if you're looking for some help building your next React and React Native project, you can reach out to us. I am the co-author of a book called React Native Cookbook. I hope, has anyone heard of it? Oh, no, yeah. Hopefully you bought a copy or pirated it. That's cool too, no problem. I've worked with React Native since I think version 0.08, so I've grown to love it deeply. And yeah, let's talk about it. Quick question, who is excited about React Native? All right, who's really excited? Let me hear it. I want to hear it yell. Oh, all right, we got one. You get a book. Who doesn't like React Native? You don't. I'm gonna give you a book just so you can. All right. So React Native, for those who aren't too familiar with it, I'd like to sum it up in three parts of it. The first part, the most important part, is React. It uses React Core as its only dependency. If you know React, you could pick up React Native. The second part, which is my favorite part, is the bridge. That's where all the magic happens, where data or messages are being transferred from your JavaScript thread to your native thread, and then in the end result is you get to render a native UI component. Now that is completely different than a hybrid or Cordova or Ionic or whatever app. We're not using a web view to render hacky CSS to look like a mobile app or whatever native platform. We're rendering the actual native components. So there's no smoke and mirrors here. All right, let's get into the good parts of it. First one, layout system. It's called Yoga. This was rewritten probably almost as many times as navigation implementations of React Native. But now finally, I think this is the last implementation. It's basically you could have a flexbox and an absolute layout, and with the combination of those two, you could lay out your applications however you want. It's written in, I believe, C++, and the way you use the React Native CSS to lay out your application is very similar to standards of flexbox and absolute positioning. So you could do nice little things like, the basic rows, columns, and these examples. So yeah, this is also using layout animation, but just the React Native version to animate these. Next thing, the animated API, because everyone wants 60 frames a second, and now we could finally get it in our React Native apps. Number one reason is because we could offload our animations to the native thread using a little property called useNativeDriver. So the animated API, cool how they implemented it, but it's on GitHub, so you can figure that out yourself. And Twitter exploding hearts, so that part's great. Now, the bridge, that's something I know a little bit more about. And quick question, anyone here has ever worked with Cordova or PhoneGap? A couple of you. Have you ever written a PhoneGap plugin? No? Did you like it? Exactly. React Native makes your life a lot easier. All you basically have to do is you take your native functionality, you wrap it with some header code abstractions. You could look it up. It's super simple, and you get to expose some cool things like fingerprint authentication and media player playback. So any sort of legacy, or not legacy, but any existing native Objective-C, Swift, or Java code you have, you could easily expose it out into your React Native application with basically a few lines. So it's great. Finally, it's just JavaScript. You could probably find the answer on Stack Overflow. It's probably there. And because it's just JavaScript, you get to use these commonly used modules. We have Redux, which I'm sure everyone knows and loves. I call it the magical state container. We have Lodash, which I'm sure everyone is using it. I like to say it ruins looping 1 underscore at a time. Hopefully no one gets offended by it. I hope there's no Lodash contributors here. And Moment, for all your date manipulation needs. Yeah. Oh, finally, the community. The React Native community, just like the React community, just like all of you folks, it's awesome. It's one of the most healthiest and supportive and just well-knit communities out there, and that's really what has kept React Native such a strong, has kept the momentum of React Native so strong. Over 50% of commits to React Native are now coming from the community, so that's a big metric. And because of that, we have some awesome implementations, which are now, a couple of them are practically first-party things. So we have Expo, React Navigation, which is finally someone figured out how to do navigation properly in React Native. It only took 5 tries, I think. And RNPM, so whenever you write React Native link, you could thank RNPM for that. Now there are some not so good parts, but these aren't horrible, I promise. They're just not great, So 1, upgrading. If you ever, let's say you build a React Native app and you deploy it to production and then you let it sit for 6 months without really maintaining it, chances are when you go in to add a feature and you go React Native upgrade, the whole app will collapse on itself and you'd probably be better off rewriting the whole thing. So there are a lot of breaking changes that happen. It's gotten better. So here's the better part. It's gotten better. And it'll get better. So now the changes are more incremental now that React Native is on a monthly release cycle. Any Android developers in the building? Couple. Okay. Do you like Android development? I wouldn't wrap anything with Android. I wouldn't do Android development at all. But it's not Facebook's fault that the Android ecosystem exists. No offense to anyone from Google. It's very fragmented. You could do a lot of native modules, and you might have weird issues with permissions and different devices and their hardware, and you're going to see all sorts of craziness. Xcode is the iOS ecosystem is a far more streamlined process, as painful as Xcode is at times as well. But Android is a little bit tough. Development mode. As you're developing a React Native application, you may forget that you're in development mode. So when you go to show off to your coworker or your buddy, hey, check out this React Native application I'm developing, and you have some animations, and you hit it and it works slower than an Ionic app, you have to remember to turn off development mode. There's a lot of profiling and debugging and all sorts of fun stuff that you're going to need as you're developing, but it really slows down the application. So you have to make an effort to remember that. And that's it. That's the only bad parts. So hopefully that didn't sound too bad. So now you're ready to start building your next React Native app. So who knows the first thing you're going to have to grab? Here's a hint. What are you going to have to grab first? A book. Who said that? All right, you get one. No, but really there's a couple of ways to go about it. The easiest, lowest level of, lowest barrier of entry is using something called Create React Native App, similar to Create React App for the React DOM side of things. But this wraps Expo, so you get a nice platform-independent way. You don't have to be on a Mac, you don't have to be on Windows. You could just target all the platforms, and you could push your app over there, so to speak, using a QR code, and you could show off your next awesome React Native app. Then you could do the standard way, which is roll your sleeves up, get into Xcode, get into Android Studio, and pull up your favorite JavaScript IDE, be it Sublime, Visual Studio Code, whatever, Atom. And just go through it. And yeah, that's the two ways about it. And that's React Native. Thank you.
Okay, let's see. I need a dongle here. Okay. Hi, everyone. My name's Carly. I am a full-stack engineer at ZocDoc in New York City. ZocDoc is a company that connects doctors and patients and allows patients to book appointments. I've done a lot of React web development. Recently, I've been working on React Native, so I feel some of those upgrading pains. But today, I want to talk to you about bringing your snapshot test to life. Okay, so first I want to talk about what snapshot testing is, the good parts, the bad parts. Then I'm going to talk about using a tool to fill some of those gaps it leaves behind. And finally, talk a little bit about how to integrate that tool into your code base. Okay, so what is snapshot testing? At its core, snapshot testing compares the output of a test to make sure it doesn't change in some unexpected way over time. The output can be a wide variety of things. It can be a value, it can be an array, an object, and frequently it's a rendered React component. Okay, so let me talk about the good parts of snapshot testing. Here's a really simple snapshot test. It's taken from the Just documentation. It's going to render a link component, which is a React component. This one links to Instagram.com, and then it's going to expect it to match a saved version of that rendered link component. So I'm going to make a small change, make it link to Facebook.com so that we can see the output when we run the snapshot test. So the output looks like this. As you can see, the href has changed to Facebook, and same with the content of the link. If we're happy with that change, we can go ahead and run this command, update snapshot, and then we'll compare against the new rendered link component for the future. Okay, so that's all great. The diff was really small, it was easy to understand, and I could really easily tell if I meant to make that change or not. Okay, so now let's talk a little bit about the bad, where snapshot testing starts to fall apart. Here is a snapshot test. This one's taken from the ZocDoc code base. It's going to render a complete booking screen, which is a screen that you would see right before booking an appointment with a doctor. I'm going to change it slightly. I'm going to wrap it in an additional div, which is something you might do in your normal day when refactoring components. And so now when we run our snapshot, I'm expecting to see maybe a few lines at the top and a few lines at the bottom that have changed. Okay, yeah, no, it's, this isn't even all of it. Like, there are tons of lines changed, and there's no way that I'm going to read through all this. So usually what I do is just go and try to check the element out myself, and then probably merge to master. Like, I mean, you can't really do too much there. The test is obviously overkill. It's really bloated. It's really heavy-handed. Nobody is going to read through all of this markup. And so it's just not a great experience. And I think in a lot of cases, I would maybe just delete the test entirely because it's not serving a great purpose. Okay, so let me now talk about a tool that we can use to help out some of these scenarios. ZocDoc uses a tool called Percy, which does an image comparison against your rendered React components. We actually first tried to build a version of this in-house, but of course it was difficult to maintain and not our core competency, and so we looked to third-party tools. And we've been using Percy. It's been working pretty well for us. Okay, so here's an example of Percy. On the left, you see the before image, and on the right, you see an after image of the same complete booking screen. And it might not be obvious looking at this what's changed, but Percy highlights in red any changed pixels that occurred to your components. So you can really easily and quickly figure out what's broken. And even like if I check this with my eyes, I'm not sure I would notice that the margin between the check mark and the edit text is actually broken here. So Percy kind of saved the day and stopped this bug from being pushed to production. If you're okay with the change, you can go ahead and hit that green approve button in the top right corner. And furthermore, you can also set Percy up to test responsive components at various screen sizes. This is something that traditional snapshot testing obviously doesn't cover at all. So it's just a great new tool to add for automating tests of responsive components. Okay, so now that you've seen an example, I'm going to talk a little about how Percy works. Just to be clear, it does not work by uploading images, so you don't need to worry about like creating a screenshot taking utility or managing a repository of images or anything like that. Percy expects HTML and CSS along with other page assets like icons and fonts to be uploaded. And it also manages the versions of the approved test outputs so that you don't have to manage those either. It'll also keep track of who approves components as they change. So if you ever need to go back and essentially do a git blame, you can also do that. Because it accepts HTML and CSS, it works with a really wide array of frameworks, quite notably today, React, but it also works with Ember and Vue, WebDriver IO, so you can plug it into a lot of different things. On that note, I'm going to talk about how to actually integrate Percy into your code base. Okay, so there's really easy integration with React Storybook. They've also recently launched integration with React without Storybook, but it is still in beta, but I encourage you to go and try it. And I set up a sort of example, one of these repositories using Create React App, and I integrated with Storybook and then also with Percy, and it took me under an hour. So at least to get started, it's pretty simple. Of course, if you have some complicated Webpack rules, then it might be a little bit more complicated, but it should still be possible. For anyone who isn't familiar with Storybook, it's basically a component library of your React components. So here I have a button, for example, this one's called a link button. This is one of my React components, and then I can, render it with different content or props. For example, I can also have a button with some emojis as the text. And then you can sort of browse through your components in all these different states. It's a great tool on its own. And here's how you define one of these stories, if you will, which is essentially one of the buttons that we were looking at here. You use this method stories of, and then import whatever your React component is, change the content, change whatever props you want to pass into it, and then it will show up in Storybook when you run Storybook. And your stories here are your Percy snapshot tests. So once you integrate Percy into your repository, it'll automatically pick up all these stories and run snapshot tests of them. So after making a couple configuration changes to your repository and setting a couple environment variables, there's not a lot, I promise, you'll add this script to package.json, npm run snapshot, and then you can run this from your local and then go to percy.io and look at any changed images there and any comparisons. It also integrates with GitHub and several different CI systems like Travis and Circle, so it can block merging. It can just report statuses on pull requests, which is really convenient. Okay, so that's a bunch about Percy. And it's been a really great tool for ZocDoc, but I do want to reiterate that I'm not suggesting that you go home and delete all of your snapshot tests. Percy should be considered like an additional layer of armor against bugs rather than a replacement for snapshot tests. Percy is a little bit more heavy-handed. I would consider it around like the component and integration level of testing, and I would consider snapshot more around unit testing. There are things that Percy won't catch that snapshot tests will catch, like a broken href, for example, wouldn't be caught by Percy, but a snapshot test would get that. But yeah, it can really help with those crazy diffs that you might be experiencing with snapshot tests, and also especially with responsive components. So that's what I have for you. Thanks, everyone. Oh, and we're hiring.
All right. Hi, everyone. My name is Kaylee. I'm a front-end engineer at Eventbrite on the platform team. And today I'm here to talk to you about the Yarn CLI and how to use it to help you build faster. So before I get started, how many of you guys have heard of Yarn or use Yarn for your projects? Similar to NPM in that it's a CLI tool, and of course this excludes the registry, but it's a tool that helps you install and manage your node dependencies. However, what made it different when it first came out was that it did so deterministically using something called a log file. And by being deterministic, it means structure. And this also has added benefits of actually being faster because it means that it doesn't have to make an extra request to the network. And it also would make the dependency requests asynchronously rather than waiting for the request to come back in order. So Jeff on the core team did a comparison around the time NPM 5 came out, and NPM 5 also made vast improvements since its previous versions. And for Eventbrite, we moved to Yarn when we were on NPM 2, and we saw a drastic speed decrease in installation time. So this was done with around 1,300 dependencies, which is great. What's even more exciting, though, is that there was a recent commit that was merged onto master using the native fs copy file module by BYK, and that brings down Yarn speed to 6 seconds, which is awesome. But actually, what I want to talk to you today about is not just the runtime speed. It's like learning the tool, reading documentation about it, and interacting with it, and configuring it for your project and your own needs, such as like integrating it with CI builds. The first thing I want to talk about is if you're a lazy developer like me, or I mean, an amazing developer who likes to save every microseconds. You like to save them keystrokes. So first thing that I like is that by default, Yarn has Yarn installs. So during this Yarn install command, it does a variety of things, which is it reads your package JSON, it resolves dependency to determine what the tree will look like, it links those modules that have once they're deduped, and then it builds those packages by running pre and post installation scripts. And with 1.0, Yarn also made improvements to running the scripts themselves. So you could, so Yarn will try to first make a smart guess based on what you're trying to run so that you don't have to type the run command. Instead, if it's not one of the native Yarn commands, it'll look in your package.json to see that you're trying to run a particular custom NPM script. And then when it passes an argument, like running a jest command, for example, instead of passing a double dash like you would previously with NPM, you would just do something like yarn test name of the test suite, which is awesome. Secondly, you could avoid manual upgrades by using interactive UI provided by the Yarn CLI. This is something that NPM actually doesn't have yet, and what I really like. So if you don't like manually updating package.json, or you want to update a bunch of them in bulk, then you could just use this tool to see which of your packages are outdated and upgrade them based on the flag you pass, such as latest or exact. Third, Yarn has a couple ways you could save frequently used flags, such as using the yarn RC or using the yarn config command. And so in this example, I'm saving the latest flag to yarn RC, which means that next time I run yarn upgrade, it would be as though if I ran it with the latest flag each time. And this is not just with upgrade. You could obviously use it with install. Maybe you always want to install it in flat mode, or you want to run it in with no emoji. I don't know, because you're a monster. I'm not going to judge. But yeah, I'm clearly not biased at all about that. Next thing you could do is customize your configurations to do other things like opt out of running optional dependencies, or opt out of running scripts. You could also save your prefix for every time you add a dependency, you could define the Semver range. A particular use case that we had at Eventbrite was we use Docker for our dev environment, and there's an optional caching container that a dev could choose to run. So whenever we detect that this container is running, we dynamically set the registry to point to that container, and we're able to reduce our build time by doing that. Fifth tip is you can make your CI run faster by using first the frozen lock file flag, which makes sure that your lock file doesn't change when you're running the command. And second thing, which is a little bit more of an advanced use case, is you could set an offline mirror. So we talked about Yarn caching by default after the initial cache population, but offline mirror allows you to always have that cache by committing tarballs into your Git repository. So with CIs, you might eventually start with a fresh install, so you might never have to install twice. So in that case, Yarn will look for this offline mirror directory before it tries to go to the network and make those requests. And the great thing is you can now run your CI in an offline environment by passing this offline flag. So we run Jenkins as our CI. Also to add, Yarn works well with a lot of different CIs like Travis and Circle. It comes built in. We found a bug in our CI where a particular package, Phantom.js, wasn't being built correctly. And thankfully, Yarn gives you some handy tools to work around those things. First thing being Yarn check. So it'll tell you, is a package installed correctly? Does it match to Semver? Does it match the hash value in the lock file? And so forth. Another command that I really like is yarn why. It'll tell you why you have a particular dependency and how you could reduce the size of your modules if you weren't to have that dependency. When we did yarn why on that Phantom.js package, we found out that, it was a weird bug because we didn't actually have it as a dependency, but we had this old version because another dependency that we were using to convert SVGs to PNGs was relying on it. And prior to 1.0, there would be no way around these nested dependencies because you have no control over them whatsoever. It applies to really large projects, maybe like Babel or Jest, where you mono repo private and you define workspaces within it, and by use them throughout your project. And the final bonus is that you could run yarn workspace command to run particular workspace lifestyle script as well. That's it. Thanks. Oh, I forgot to add, running Yarn with 1.0 also resolves your merge conflicts magically, so that's awesome. Really gets you out of trouble. Thanks.